In this writing clinic, we're going to talk about how to present t-test results to a scientific audience. We're going to review 3 published studies and how they presented t-test results, but also how to write effectively in a scientific setting. Okay, so let's take the first study we're going to look at is one by Forsyth and colleagues. This was in 2008. And what they were studying was the effect of cognitive behavior therapy intervention on hospitalized inpatients for depression. The measures that they used were the ATQP and the ATQN. That's the automatic thoughts questionnaire, positive thoughts, and automatic thoughts questionnaire, negative thoughts. And that questionnaire is really designed to get participants to rate or estimate the frequency magnitude of the type of thoughts that they're having. And obviously you would expect at admission that depressed patients would have a high frequency of negative thoughts, low frequency of positive thoughts, and then after treatment that should reverse, right? So obviously, since we're looking at the same patients during the pre-test and then the post-test, this has to be a matched sample or dependent t-test, right? Because we're looking at the same folks and measuring them twice and then looking for differences in the mean scores from the pre to the post testing. Also, the Beck Depression Inventory was given to these folks pre and post, and then the question becomes, are there significant differences between the means prior to treatment and the means after treatment? Now, what's interesting in this study is that they give us a table. There's age, gender, race, and then the diagnoses that they use. And I really like how they did here, where they broke this down by the frequency of the diagnoses. That gives you some idea for these participants what you were looking at. The issue, though, with this study and the way they reported it is that this is the last time we see these data. So they present us the participant demographics, but they don't interpret the results in terms of these classifications at all. In fact, we're going to get the results here in just a second, but at no point do they mention whether or not the results hold across on another. Everybody's just kind of lumped together, and that really removes from the richness of the interpretation, and you're going to see what I mean in just a second. Presented it in a table to the reader regarding the automatic thought questionnaire results. So they report the mean plus standard deviation and the median at admission and at discharge. And then you'll notice there's a column to the right that says change in score. Okay, now the change in score in a matched sample t-test is also referred to in statistical jargon as the D score, capital D. And that means the difference. In this example, the participants had a mean of 72.0 on the admission of the at admission on the ATQ negative subscale, and a mean of 38.7 on the ATQ positive subscale. Now, if treatment's working, you would expect this number here to go down by discharge, and it does. It goes from 72 to 38. And the positive score should go up, right? So it's at 38.7 here, and it goes up to 61.4. Well, that's all, excuse me, that's all pretty consistent with what we would expect to see in successful treatment, or at least, if not successful treatment, at least remission of symptoms. You come over to the change score then as a result, that 38 minus 72 is negative 34.0. So you should see a negative score here for the change on ATQ negative, positive score for ATQ positive. Then they record the p-value. What's the probability that this different score would occur by chance or measurement error? And the probability of that occurring by chance or measurement error is less than 1 in 1,000. So p is less than 0.001. The chance that you would say, or the probability that you would see a gain in mean scores of 22.7, again, very slight, less than 1 in 1,000. Now what's interesting here is they don't report the actual t-score, the test statistic itself. They report p, but they don't report the t-score, the t-test result, nor do they report effect size. So I thought, okay, so I'm reading this and I'm thinking, okay, that's not there, but I bet you they report that in the results section itself. Well, here's the results section, and let's just go through this. With depression who participated in the CBT group, completed the tools at admission and discharge, and had not received ECT. That's electroconvulsive shock therapy. which is used only in very severe cases. 40.6 years, standard deviation of 13.2. 67% were females and most were Caucasian. All had some type of affective diagnosis, with the most common being major depression. Many had additional diagnoses. See the table that we just looked at. The mean number of CBT groups attended was 3.1. So they didn't attend a ton of CBT group sessions, but they attended a few. Now, you immediately should be saying here, okay, well, you know, lots going on with these folks. I mean, yeah, they're going to CBT group sessions, but they're having all sorts of other sessions as well. So any change here in positive or negative thinking, it might be due to CBT. It could also be due to the fact that they're just being treated, period. You know, there really is no control group of folks who aren't being treated. So this is an uncontrolled study. So as a reader, all of these things are kind of going through your mind, and you're saying, okay, well, how confident are we that the results we're going to see are really due to the treatment? And right now, because I know immediately it's an uncontrolled study, I say, not so confident. I mean, the results are consistent with effective CBT, but not so confident that they're entirely due to that. So they give paired, we know it has to be paired, and that resulted in what they found in the paired t-test was that there was a significant change in thinking, right? And the probability of that occurring by chance or measurement error is 0.01 between admission and discharge. And I highlighted these parts here because as I'm reading this, I'm thinking, you know, I really am not crazy about how they presented their information here. Okay, and I'm going to show you why in just a second. But before I do that, again, let's go back and review what it would mean to do a pre-post t-test that's a dependent t-test. Okay, so the analysis that they're doing using a dependent t-test looks kind of like this. Let's imagine we have participants, and I say, okay, participant A, maybe Joe, Mary, whatever, A, B, C, D. Okay, we gave them the ATQ on a pre-test, and let's say they got a score of 22, patient B, score of 34, patient C, a score of 43. That's their pre-score. Then we gave it to them again after they've had those 3 therapy sessions, and then here's their scores, okay? Again, and we're saying, let's say this is the negative version of the ATQ for negative thinking, then we should see all of these post scores going down, right? But what the null hypothesis would say is that if we calculated different scores for patients, in other words, we're comparing each patient's pre to their post score, and we're effectively subtracting out the pre from the post score, then the sum of all of those different scores should equal 0, right? So here's our D score, and for patient A, the difference between post and pre is 5 points, -5. The score went down on the scale by 5 points. For patient B, it went up 1. For patient C, it went down 1. For patient D, it went up 5. So when you summed all those D scores up, it comes out to 0. That would be dead on consistent with the null hypothesis, that there's really no relationship between the treatment and changes in those D scores in the desired direction. But they're actually reporting significant changes in the desired direction. Okay, so in that case, where we are rejecting the null hypothesis, we might have something that looks quite different. So the pre-scores here I just kept the same, but then I changed these post scores so that they're all pretty much going down. So in the first case, that score went down by 5. The second case, it went sum up. Okay, that's sigma. The sum of all the D's is -44. Okay, so when you sum up all of those D scores and it's -44, now the question becomes, is -44 different enough from 0 for us to reject the null hypothesis? And that's really the foundation of a dependent t-test. Okay, and in this case they call it paired sample t, paired t-test, all means the same thing. Okay, now we go down to the next paragraph, and here's where I'm going to begin to focus more on the writing. Okay, and what they write in the next paragraph is changes in BDI-2 scores between admission and discharge were significant and a negative. They actually spelled negative, which is interesting. I don't know if I've ever seen that before. 19.1, and then they reported the N rather than degrees of freedom, the standard deviation, and then a p-value. These changes were in the appropriate direction when correlated with the ATQ, that is, as the BDI-2 scores, all ATQ-P scores went up. I don't know why they need to include that, because that write-up came out to be over 80 words. And what I would recommend is that instead of writing it up like that, we could really shorten it down and make it more concise. And here's the way I would write it. I would say participants showed a statistically significant decrease in scores on the ATQN, and then I'd put it in APA format, and I'd say, okay, t-test, the degrees of freedom right here, equals negative x point xx. That would be the t-score, the test value that we actually calculated, which they don't report anywhere in the manuscript. P is less than 0.001. I got that from the table. And then I'd report the effect size, again, which they did not report. And a statistically significant increase in ATQ p-scores, and that would be t 425 equals x point xx, p is less than 0.001, effect size from pre to post test. Mean changes in BDI-2 scores from admission to discharge were also statistically significant in the desired direction, and then I'd report it, making sure, because it's in the desired direction and BDI scores would go down, this t-score would have to be negative. So I was able to drop tightly expressed, more compactly expressed. That's the kind of language, as a reviewer, and I do a lot of manuscript reviews, that's the kind of language I want to see in a journal. I can read that quickly. I know what's going on. I don't need to be told, for example, that as BDI scores lessened or the brief hospitalization ATQN scores went down. I know that from reading this. I know right here the fact that this result would have had a negative T tells me everything I know in relation to these other scores for the ATQ and the ATQ-P. Okay, so that's a good example of how one group of authors reported results, how it could be better, and let's go on to the next example. Okay, in this study, we're looking at t-test results, and really the nature of the study is not that important. Let me just tell you what they're trying to report here. What they're trying to report here is whether or not the self-reports of aggressive behavior from teachers about the students' behavior. Okay, so students are rating themselves, and teachers are rating the students. If those reports were equivalent at the pre-test stage, in other words, were there statistically significant differences between so what they're trying to show here is that the groups themselves were equivalent at the start of the research study. And that's important because you don't want the groups to be different on the dependent variable, because if they're different on the dependent variable at the beginning, any differences at the end are going to be difficult to interpret. So let's read here what they say in the paragraph. It says, the main research question referred to the effectiveness of the suggested intervention in increasing adjusting behavior of maladjusted students, and particularly in reducing their aggressive behavior. The effect was measured via self and teacher reports. Owing to missing data, N was 63 for self-report and 68 for teacher report. A preliminary analysis indicated no differences on the pretest general scores between experimental and control groups. And then the t-test is reported. Notice how this is different from the previous study, where they actually report T, they report degrees of freedom right here in a format that's a little unusual because they report both between and within. And then they report the t-test result, and then the p-value. What they don't have here is an effect size, which I'd really like to see, but they do report the p-values, and you'll notice these p's are both greater than 0.05. So these are going on in this paragraph, so let me simplify what they're doing. Okay, first of all, they are saying they are measuring the effect of the self and teacher reports. They are then reporting the t-test results, and so that first part of the report there tells us what kind of test it is, and it says that T is what gives us the test, and it also tells us approximately how many participants were in the condition of the rating. The test statistic is then reported, and that's expressed in standard error units, which you don't really need to know about right now, but what you should know is that as we get results that are closer to the value of 2, whether it's plus or minus, doesn't matter, but as we get closer and closer to 2, what that means is we're getting closer and closer to rejecting the null hypothesis. And this one almost had the null hypothesis rejected. Probability was 0.07. So it almost made it. These groups were almost different enough to reject the null hypothesis, but didn't quite get there. So if we look at then sort of the design of how this was set up, you have a condition here in which aggressive students are self-reporting their levels of aggression. There's a teacher report, okay, regarding the levels of aggression in those students. And then the students have been divided into a control group and an experimental group. And so they are providing us a pre-test score of their self-reported levels of aggression for the control group, and then a pre-test score of their self-reported levels of aggression for the experimental group. And when we look at comparing these two means, right, the mean for the control group and the mean for the experimental group, we know right away that these are independent samples t-tests that's going to be run here, right? Because the folks in the control group are not the same as the folks in the experimental group, and there's no indication that they've been matched on any important variable. So that's rotation, where it says t 1 comma 61 equals negative 1.83. P is less than 0.07. That's what's right here. Okay, that's what's right here. And so that's this is an independent samples t-test. Then it's reported for the teachers, the same kind of result for the teachers, where they was looking at a rating of the students who have been put into the control group and a rating of the students who have been put in the experimental group. These are different groups, not the same kids. And so that ended up with a result that was also non-significant, telling us that these groups, from the teacher perspective, were about equally aggressive. And let's go to our third and final study that we're looking at. This is by Fakar. A lot of the things that you see here kind of spread across cultures. And this was a relaxation exercise of patients who have experienced severe burns. And what they're trying to do is reduce the perceived pain that these patients have by teaching them to relax their jaws while they are undergoing a skin grafting procedure where a dressing was put onto their skin, which apparently I didn't know how painful that could be. Apparently it's incredibly painful. And so using jaw relaxation to reduce anxiety, that was the behavioral intervention here. So what I like about this study is, and you see this more and more now, is you'll see these flow charts of the design and method. And so in this study there are 116 eligible participants, 9 were excluded. The reasons for the exclusion are presented here. I won't go into that. That left 107 that were then randomly assigned to either the control or of those participants were assigned to the jaw relaxation condition, 52 to the control group. Okay, of the 55 that went to the experimental condition, 5 were lost to follow-up, and they even provide the reasons for that. That left 50 in the analysis for the treatment group. 2 in the control group were lost. That left 50 for the analysis. So, you know, not a bad situation here. We've got 50 in the treatment group, 50 in the control group, and so what we're going to test is whether or not in perceived pain. The null hypothesis would be that it does. Levels of anxiety after the treatment should be just as high as what we would see in the control group that had received no treatment. So in standard deviations of participants, pain, anxiety in the experimental and control group. And what's interesting about this is that you have a row here that says, okay, before intervention, what was their pain, anxiety about this procedure? And the mean comes out at 49.94 with a standard deviation of 22.76. What that tells me is I've got a mean of 49 but a standard deviation of 22. There is a lot of variation in these subjects in terms of how anxious they are. A lot of variation. I mean, 2 standard deviations, you know, out would take us to a range from 5 to, what would that be, 44 plus 49 would be 93. So 2 standard deviations out and you have a range from 5 to 93. So that's a lot of variation. But anyways, they're at 49.94 for the experimental group, 51.10. And then the question is, you know, is that difference between those two means, is that statistically significant? The p-value is 0.78, and the answer is no, it's not statistically significantly different. So these are relatively equivalent groups to begin with. And of course, that's an independent samples t-test because you have different subjects in the experimental group than the control group. The other independent samples t-test that they could run is at the post-test after the intervention is given and the dressing is put on. The experimental group reported anxiety about this procedure at 44.77 and the control group at 53.54. So that difference right here just bordered on significance. They report it as statistically significant. If they rounded, it's at 0.05. Be right there on the border whether or not this true. Those analyses right there obviously are between group analyses. So independent samples t-test would be appropriate, but we could also look within condition, right? So we could look at the experimental group, right? And we could compare before intervention and then say after intervention and look at those means. Or we could say after the jaw relaxation intervention, but before the dressing, and then after the dressing has been put on, look at those means. Okay, if we do it this way within condition, now we're talking within subjects dependent t-test, also called paired t-test, paired sample t-test, and so forth. We wouldn't really call it matched though, because when you say matched, that means different subjects matched on a variable. And then in the control condition, we look at the difference in those means right there. Now what's interesting in this table is they don't report the significance levels for these kinds of analyses, even though in their narrative they focus a little bit more on the within subject dependent t-test results, the paired t-test, rather than the independent samples. So let's go to that and take a look. Oh, before we do that, let's look at the graph. So here's the same data that's in that table, but graphed out, and what you can see is that in the control group, from the point before intervention to the point after the dressing, we see just this little increase in overall anxiety surrounding the procedure. For the experimental group, we see here's before the jaw relaxation intervention, here is after the jaw relaxation intervention. They had a drop in reported anxiety. Then they got the dressing and their anxiety about it went up a little bit more. And so the question is, did that increase right there? Is that a statistically significant increase or not? And so we've got a number of analyses to look at. So we could, again, the between group analyses look like that, comparing the means here to each other and then comparing the means here to each other. The within analyses, which would be more of the dependent that, right, where we're looking at the mean here comparing to the mean here, or the mean here, the mean at the other end. Okay, so here's their write-up. They say, regarding the first hypothesis, the dependent t-test show before and after intervention in the experimental group. And again, they report only the p-value here, not the t-test score. I would like to see the t-test score. And they also don't report effect size, because I can tell you if your p is bordering right at 0.05, the effect size is not going to be huge. It's not going to be huge in this case. But it would be nice to know what it is. Our second hypothesis after intervention demonstrated no significant difference between mean pain anxiety scores before and after dressing in the experimental group. There was no significant difference between the mean pain anxiety scores before and after dressing in the control group. Moreover, our third hypothesis, independent t-test, showed significant difference between the mean post-dressing pain anxiety scores and the experimental control group. So let's go through and look in the table to see what they're referring to, because this write-up here is simply describing what's in this table. So the first one, they say, the dependent t-test showed that there was a significant difference between mean pain anxiety scores before and after intervention. Here's the comparison that they're making, right? So they're kind of saying, okay, look at that mean before intervention, look at the mean after intervention and or dressing, and it's gone down from 49.94 to 44.7. That is in fact statistically significant, even though they're not reporting the t-test value at any point. The next one that they looked at was our second hypothesis, after intervention, demonstrated no significant difference between mean pain anxiety scores before and after dressing in the experimental group. Okay? And then the third thing, there it goes. Okay, I guess both of them are going to pop up. It says there was no significant difference between mean pain anxiety scores before and after dressing in the control group. So that's right here, 51.10 compared to 53.54. And then finally they report the independent t-test, that's in red, going this way. Okay, and you know that because it says 0.048. That says 0.048. So what they're reporting right here is exactly what's in the table. They're not reporting everything I'd like to see. There's no t-test result. There's no effect size. So this would have a hard time getting published in an APA journal. So when you're reporting that t-test result, here's what you're focusing on. Here's the t, that tells us what type of test it is, the degrees of freedom. How that's calculated depends on the type of test that you're using, and we're not going to go into a lot of detail. All you need to really know is that the degrees of freedom are pretty close to the sample size, either off by 1 or 2 points. But it's a good way to understand essentially the size of the study in terms of the number of subjects. The test statistic is then reported. The p-value, the probability level that the test statistic result is due to chance or measurement error, then comes. We want to see that value less than 0.05 in most cases. And then finally the measure of effect size. So if I'm writing up the t-test result, it's going to look something like this. So if I said t 104 equals negative 2.53, p is less than 0.01, d equals 2.14. What I'm saying is, okay, I used the size, was around 105 or 106. The result of the t-test yielded a value of negative 2.53, which means the mean of my experimental group was 2.53 standard errors below the mean of the control group, or the comparison condition. Now, whether that's a good thing or a bad thing that doesn't tell us until we know something about the study, right? And this is p is less than 0.01. The probability, what that means is the probability that I would observe a t-test result of negative 2.53, the probability that that would be due to chance or measurement error, given my sample size, is less than 1 in 100. Therefore, I'm going to reject the null hypothesis that there is no treatment effect, or that there's no relationship between the treatment and the scores on the dependent variable. I'm going to reject that notion. So I've rejected the null hypothesis, and there is an effect size measured here in standard deviation units of 2.14. And that's going to be a pretty large effect. Okay? So that would be an example of how to write up the actual t-test results in APA format. Okay, that's the end of the writing clinic for t-test. Hope you enjoyed that. I know it's a lot of information, but I'm hoping that at this point you've gone through these videos, and in a relatively short period of time you can really sort of understand what the t-test tells us and how to report it.